Right now, 94% of every galaxy captured in the deepest photographs ever taken by human instruments is already unreachable, not destroyed, not collapsed, not dead, just gone carried beyond a boundary that no engine, no signal, no prayer will ever cross. You are not looking at the universe. You are looking at a memory burned in a light that left its source billions of years before Earth existed. And it gets worse. The James Webb Space Telescope was designed to see the infancy of creation. It succeeded beyond every expectation, but hidden inside its data is a confirmation that astronomers hoped would never come. The universe is not just expanding, it is accelerating, and the rate of that acceleration contradicts our most trusted models of reality. This is not a technical footnote buried in a journal. This is the sound of a cage door closing, slowly, permanently, around everything we are and everything we will ever be. To understand what is happening, you must first understand what is already gone. The Boötes Void sits approximately 700 million light-years from Earth in the direction of the constellation Boötes. It is a sphere of almost perfect emptiness stretching 330 million light-years across. Inside this volume, where statistical models predict roughly 2,000 galaxies should exist, there are 60. 60 dim points of light scattered through a darkness so absolute that the human mind struggles to process it. If you could teleport Earth to the center of the Boötes Void, the night sky would be almost featureless. No Milky Way arching overhead, no Andromeda smudge on the horizon, no clusters, no filaments, no cosmic web glimmering at the edge of perception. Just blackness. Total, uniform, suffocating blackness with perhaps a handful of faint smears visible only through the most powerful telescopes. A civilization evolving there would have no concept of a populated universe. Their cosmology would be built on emptiness. They would assume that existence itself is sparse, that matter is rare, that the default state of reality is void. They would be wrong about the present, but accidentally correct about the future. Because the Boötes Void is not an anomaly, it is a prophecy. In the coming billions of years, expansion will transform the entire observable universe into a Boötes Void for every civilization that survives long enough to witness it. Not because galaxies will be destroyed, because they will be moved silently, invisibly, irrevocably beyond the reach of light itself. The mechanism behind this is elegantly simple and terrifyingly absolute. In 1929, Edwin Hubble observed that distant galaxies are moving away from us. The farther they are, the faster they recede. This relationship is quantified by a single number, the Hubble constant, designated h0. It describes the rate at which the universe expands per unit of distance. For decades, pinning down this number was a matter of technical refinement. Better telescopes, better distance markers, better statistics. The assumption was that all methods would eventually converge on a single value. They did not. The Planck satellite mapped the cosmic microwave background, the faint thermal afterglow of the Big Bang, with extraordinary precision. From this data, physicists derived a Hubble constant of 67.4 kilometers per second per megaparsec. This means that for every 3.26 million light-years of distance, galaxies recede 67.4 kilometers per second faster. But local measurements tell a different story. Using Cepheid variable stars and type I supernovae as cosmic yardsticks, astronomers consistently find a value closer to 73.0 kilometers per second per megaparsec. The gap between 67 and 73 might seem trivial. It is not. In precision cosmology, where models are calibrated to fractions of a percent, This discrepancy is seismic. It has a name, the Hubble Tension, and it implies that either our measurements are flawed or our understanding of the universe is fundamentally incomplete. The James Webb Space Telescope was supposed to resolve this. Its infrared sensors can observe Cepheid variables in galaxies where Hubble's resolution was marginal. The hope was that Webb would reveal systematic errors in the older data, nudging the local measurement downward to match the cosmic microwave background prediction. In 2023 and 2024, the results came in. Webb did not find errors. It confirmed the local measurement with even greater precision. The expansion rate is 73, not 67. The tension is real. It is not an artifact of imperfect instruments. It is a feature of reality. This means one of several things, and none of them offer comfort. The first possibility is that dark energy, the mysterious force driving accelerated expansion, is not constant. The standard cosmological model treats dark energy as a cosmological constant, a fixed property of space-time with a uniform density that does not change over time. But if dark energy is dynamic, if it strengthens as the universe ages, then expansion is not just accelerating. It is accelerating faster than we predicted. The cage is tightening more aggressively than our equations anticipated. Recent analysis of Webb data combined with baryon acoustic oscillation measurements from the Dark Energy Spectroscopic Instrument has produced tentative evidence that dark energy may indeed be evolving. The equation of state parameter, which describes the relationship between dark energy's pressure and density, appears to deviate from the value of -1 that a true cosmological constant would produce. If confirmed, this would mean the expansion rate is not merely high, it is increasing. The accelerator pedal is being pressed harder with every passing epoch. The second possibility is that there exists a form of energy or matter that we have not detected, something that interacts with the geometry of space-time, but not with electromagnetic radiation. Invisible, pervasive, and powerful enough to alter the expansion history of the entire cosmos. Some theorists have proposed early dark energy, a burst of accelerated expansion in the first few 100,000 years after the Big Bang that would reconcile the two measurements. Others have suggested new particles, new fields, new physics entirely. The third possibility is the most unsettling. General relativity, the most successful theory of gravity ever formulated, may be incomplete at cosmological scales. Not wrong in the way Newtonian gravity was wrong, but insufficient. A brilliant approximation that breaks down when applied to the full scale of the universe. If this is the case, then our map of reality has blank regions we have not yet discovered, and the territory those blank regions conceal may be hostile to everything we hope. 4. Regardless of which explanation prevails, the practical consequence is identical. The universe is expanding faster than our models predicted. The cosmological event horizon, the boundary beyond which light can never reach us, is closer than we thought, and it is contracting. Let me be precise about what this means. The cosmological event horizon is not a wall. It is not a physical barrier. It is a mathematical consequence of accelerated expansion. Beyond this horizon, the space between us and distant objects is growing faster than photons can traverse it. Light emitted from galaxies past this boundary will never reach Earth. Not because it is too faint, not because it is absorbed, because the space it must cross is expanding faster than it can travel through it. Today, the event horizon encompasses approximately 16 billion light-years in every direction. That sounds enormous. It is not. The observable universe, the sphere of space from which light has had time to reach us since the Big Bang, extends 46.5 billion light-years. The event horizon is already smaller than the observable universe. We can see galaxies that are already beyond our reach. This is worth repeating because it is the single most important fact in this narrative. We can see them. We can photograph them. We can measure their redshift, analyze their spectra, count their stars. But we can never visit them. We can never send them a signal they will receive. We can never receive a signal they send after this moment. They are visible ghosts. Fossils of light from an era when the universe was smaller and the distances were crossable. And every year, approximately 20,000 more stars cross this horizon. 20,000 suns, each potentially orbited by planets, each potentially harboring chemistry or biology or minds. Gone. Not destroyed, removed, placed beyond the reach of any technology, any speed, any amount of energy, forever. The mathematics of escape are brutal. To travel at 10% of the speed of light, a modest 1,000-ton spacecraft would require approximately 450 petajoules of energy. This is roughly equal to the total energy consumption of human civilization for an entire year, concentrated into a single vehicle, and 10% of light speed is pathetically slow on cosmic scales. At that velocity, reaching the Andromeda Galaxy would take 25 million years. Reaching the Virgo cluster would take 540 million years. And both of these are practically neighbors. But the real problem is not speed, it is the treadmill. At 0.1 times the speed of light, any galaxy beyond approximately 1.4 billion light-years is already receding faster than you can approach it. You will never arrive. Not in a billion years. Not in a trillion. The space between you and your destination is being manufactured faster than you can consume it. You are running on an expanding surface, and the expansion rate exceeds your stride. Even at the speed of light, the absolute and inviolable limit imposed by the structure of space-time, the horizon problem persists. You can only reach objects currently within the event horizon. Everything else is forever beyond contact, and the event horizon is shrinking. Every moment, the volume of reachable universe decreases. This is not an engineering challenge. Engineering challenges have solutions. This is a geometric property of space-time itself. It is woven into the metric that defines distance and duration. To violate, it would require rewriting the laws of physics, not in a metaphorical sense, but literally. You would need to alter the relationship between energy, mass, and velocity that governs every particle in existence. No known physics permits this. No speculative physics offers a plausible pathway. Warp drives require exotic matter with negative energy density, which has never been observed and may not exist. Wormholes, if they can be stabilized at all, require quantities of energy that exceed the total output of stars. These are not technologies waiting to be developed. They are mathematical curiosities that may have no physical realization. We are confined, not by our lack of ambition, not by our primitive technology, by the architecture of reality itself. Now project forward. In approximately 4.5 billion years, the Milky Way and Andromeda will collide and merge into a single elliptical galaxy. Astronomers have already named it Milkdromeda. It will be a massive, slowly rotating cloud of aging stars, depleted gas, and cooling remnants. By that time, nearly every galaxy beyond the local group, our small gravitational neighborhood of perhaps 80 galaxies, will have crossed the cosmological event horizon, the cosmic web, that magnificent structure of filaments and clusters stretching across billions of light years, will be invisible, not because it will have been destroyed, because the light from it will no longer reach us. Astronomers in Milkdromeda will point their telescopes outward and see nothing. No galaxies, no clusters, no large-scale structure, just emptiness in every direction, extending to infinity. In 100 billion years, the cosmic microwave background, the last physical evidence that the Big Bang occurred, will have redshifted beyond detection. Its photons, stretched by expansion to wavelengths longer than the observable universe itself, will be indistinguishable from quantum noise. A physicist born in that era will have no evidence that the universe was ever anything other than a single galaxy surrounded by void. No expansion to measure, because there will be nothing to measure it against, no background radiation to analyze, no distant objects to provide redshift data. They will construct their cosmology from what they can observe. One galaxy slowly dying, floating in infinite darkness. They will likely conclude that the universe is static, finite, and eternal. They will be wrong about all three, but they will have no way to know it. The evidence will have been erased, not by censorship or catastrophe, by the patient, relentless, indifferent expansion of space. In 1 trillion years, star formation will cease. The molecular clouds that serve as stellar nurseries will have been consumed or dispersed. The last red dwarfs, those miserly furnaces that burn hydrogen so slowly they can persist for trillions of years, will begin to flicker and die. In 100 trillion years, the last star will exhaust its fuel. The universe will enter what physicists call the degenerate era, populated only by white dwarfs cooling toward absolute zero, neutron stars spinning down into silence, and black holes slowly evaporating through Hawking radiation over timescales that dwarf the current age of the cosmos by factors of billions. Eventually, even the black holes will be gone, and then nothing, no light, no heat, no structure, no change, just particles drifting through an infinite void, each one so far from the next that no interaction between them will ever occur again. This is the ultimate fate that the Hubble tension illuminates, not with certainty, not with the clean precision of a solved equation, but with the cold weight of converging evidence. The universe was born in fire and light. It will die in ice and silence. And the transition between those states is not a distant abstraction. It is happening now. Measurably, observably, the Webb data confirms it. We exist in a narrow window, a sliver of cosmic history where the universe is still bright, still populated, still knowable. We can see 2 trillion galaxies. We can detect the afterglow of creation. We can measure the rate at which our prison walls are advancing and understand, with mathematical precision, what we are losing. No future civilization in this galaxy will have this knowledge. The evidence will be gone. The cosmic microwave background faded to nothing. The distant galaxies carried past the horizon. The expansion itself, unmeasurable in the absence of distant reference points. We are the last generation of cosmologists who will ever understand the true scale of what exists. Every generation after us will know less, will see less, will understand less about the nature of the cosmos they inhabit. This is not a failure of science. It is a feature of the universe. Knowledge itself has an expiration date written into the geometry of space-time. We are the witnesses, the only minds in the entire future trajectory of intelligence in this galaxy that will comprehend the full scope of what was, that will hold in our data the image of a universe teeming with light, connected by filaments of matter, animated by the residual heat of its own birth. After us, the evidence vanishes, the windows close, the lights go out one by one, galaxy by galaxy, photon by photon, and the great nothing, that vast and patient emptiness that already fills the Boötes Void, will become the only reality anyone will ever know. We did not choose this role. We did not earn it, but it is ours. We are the final observers of a vanishing infinity, the last eyes that will ever see the universe as it truly is. And when we are gone, when our instruments fall silent and our records decay, the cosmos will continue its expansion in perfect, absolute, eternal indifference. Not cruel, not kind, simply indifferent. And indifference at the scale of the universe is the coldest thing there is.